Okay. One sample Z procedure versus one sample, no, actually it's two samples, sorry. Two sample Z procedure versus two sample what? T procedure. Okay? When we use X bar minus Y bar to estimate mu X minus mu Y, okay? Why is that? Because the sampling distribution of X bar minus Y bar, its center is precisely the unknown parameter you want to estimate. This is a very desirable property. In more advanced book, they call this is what? Huh? X bar minus Y bar is an unbiased estimator of what? Mu X minus mu Y. Okay? And that is to say it's mean. That is to say the mean of the sampling distribution is precisely the unknown population parameter you want to estimate. That's a very desirable property. So if we want to form what inference, we standardize the estimator. X bar minus Y bar, subtract by its mean, divided by standard deviation. Okay? X bar minus Y bar, subtract by its mean, divided by standard deviation. We're gonna get X bar minus Y bar, subtract by mu X minus mu Y, over square root of sigma X squared over nx plus sigma Y squared over ny. Okay? Are you with me? Look at here. X bar from the first sample, Y bar from the second sample. So you see what? Two samples. After you standardize it, what do you get? You get Z. This is standard normal. Okay? Any random variable, subtract by its mean, divided by standard deviation. You're going to convert to Z-score. Okay? So this Z is what? Standard normal. Standard normal means its mean is 0, its variance is 1. So one sample, two sample. If you standardize it, you get Z. This is called two sample Z procedure. Okay, this is called two sample Z procedure. But in the most real life application, sigma X squared and sigma Y squared are unknown to us. So in this case, they are estimated by sample variance They are estimated by what? Sample variance, okay? So the resulting statistic, X bar minus Y bar, subtract by mu X minus mu Y. over Sx squared over Nx plus Sy squared over Ny. Okay? When you don't know population variance, you estimate by sample variance. Or you say when you don't know population standard deviation, you estimate by sample standard deviation Sx. The resulting statistic is no longer follow what? A z. This is a new distribution called t. But it's not exactly just what? Just approximately. Okay? Just approximately. Nu. For nu, there are two ways people calculate it. Nu is equal to what? Minimum. Nx minus 1, Ny minus 1. For our example, Nx is 3, Ny is 4. So the minimum is what? The minimum is 3 minus 1 is 2, 4 minus 1 is 3, the minimum is 2 for our example. Okay? This is one way people do it. The other way, this formula is very complicated now, okay? This is Sx squared over Nx plus Sy squared over Ny. You add them up, you square them, okay? And then 1 over Nx minus 1, Sx squared over Nx, the whole thing squared, plus 1 over Ny, Sy squared divided by Ny, and whole thing squared. Okay? There are two commonly used formula to compute this approximate degree of freedom. Usually, people use this one. But if you want to get better calculation results, use this one. But this one looks very complicated, okay? So most of the time, people use this one, and computer software package use this one, okay? For your final exam, I will tell you clearly which one you should use, okay?